Okay, let's have some fun. If you followed along with all the Ape tutorials so far, you have all the tools it takes to use Ape to directly launch new markets against Curve's Llama Lend. Let's dive in. Behind me is the smart contract source code for the one-way lending factory. This is part of the new Curve isolated lending markets, popularly known as Llama Lend, that allows anybody to deploy their own lending vault containing 2 tokens and the same soft liquidation protection that made crvUSD so great. But unlike crvUSD, there's no need to have DAO gatekeeping because these vaults are all isolated. Which means you, if you know how to use Ape, could go ahead and use this smart contract to launch your own factory. Now, of course, by the time you're watching this video, it's possible there's a UI, so you could just do it straight through the web. But sometimes Curve launches these smart contracts and says, have at it. And you need to have power skills with Ape to be able to do so. Fortunately, by the end of this tutorial, you'll be able to launch your own smart contract. So at the moment, this hasn't even been deployed to mainnet as of the time I'm recording it. But through a little bit of clever sleuthing, I was able to find out that somebody actually deployed this entire branch to Polygon scan almost a month ago and has even been testing against it by creating a smart contract. So you can dive into it. This final contract here, ED4, I've happened to confirm is in fact the smart contract factory. And it's been used to deploy this pool here, which if you look at the logs, it is actually a lending market where you are supplying wrapped Ethereum as the collateral token, and you can use that to borrow as much staked DAO SDT token as you'd like. So what we're going to do is we're going to use Ape to inspect this transaction, figure out the parameters that it used to launch this vault, and we'll launch the exact opposite vault because this is a one-way market, so you could only use it one direction. So we'll do the opposite where you could supply staked DAO token as collateral and use it to take out wrapped Ethereum. So let's dive in. In order to do this, you're going to need to do a little housekeeping before you get your terminal set up. You have to make sure, of course, that you have the Ape Polygon plugin installed. You'll probably want to export your Polygon scan API key into your environment variables for ease of use. And you're going to want to pull in the Curve contracts for the isolated lending markets on the lending branch so that you have access to this, because if you look at the smart contracts here, the smart contracts have been deployed, but they're just bytecode. They have been verified. There's no source code on it. Ordinarily, if you have Polygon scan, it's just going to pull the source code directly from the verification. With no verification, we're going to have to use the ABI itself. So for this reason, we're going to just use the actual contract here, and we're going to use Viper to pull the ABI from it before we get started. So if you have Viper installed in the command line, then you can look into this contracts lending and take a look at the one-way lending factory. This will give you the full bytecode. We don't need the full bytecode. We want to format it as a ABI. And we're going to store this in factory.abi. And you can do the same if you want to be able to read the vault contract. We can put this in vault.abi. And then over here, we fired up using Hardhat node, a Polygon mainnet fork. We're going to go ahead and just import the JSON library and use this to read the ABIs. JSON.load, open factory.abi. And we'll see that now we have a working factory ABI. We'll do the same for Vault ABI. All right, now all we need to load our factory contract is its address. So we'll go over here and grab it. Call this the factory address. And now, given these 2 parameters, we can create a contract object using the ABI is equal to factory ABI. And now, just as if it had been verified on Polygon scan, you have the full access to all the methods within factory. So we know that this particular one has 1 market created so far. This has been deployed to OX425. which we should see matches up with this here. If we toss 425 in, we should find that in fact exists on Etherscan as basically a shell template contract with a few parameters. So this is the contract we could interact with if we want to play with it. No one's yet tried to do so. If you want to load this as a vault, you can basically say factory.vaults0 and then pass the vault ABI that we loaded earlier. And you can see that the vault, let's say contract vault dot collateral token, as we described, dot name. This should be wrapped ether, and the vault borrowed token name should be staked out token. So we've confirmed this vault is the same. What we'd like to do now is we'd like to figure out what parameters were used to launch this so we can just kind of mimic those parameters for ourselves. So what we can do is we can look at the transaction that created this here. This is transaction hash C1CC. And more details, let's just grab this kind of bytecode that we can't understand. And in a previous tutorial, we saw how we could use this to basically decode. So we'll call it input bytes. And what we used was this built-in Python bytes to get this from hex. We'll paste this in, and now we have input bytes that we can work with. So if we use factory to decode this input because it now understands the API, this gives us all the information we could need. So we'll set these as our parameters, just the params1. And we can now use the factory create from pool. And we'll do params collateral token first because we're doing the reverse, followed by params borrowed token. Then params A, params fee, params loan discount, params liquidation discount, and params has to launch against an existing curve pool. Then this curve pool has to have Oracle, basically one of the new generation pools. So all the params are the same, except we've flipped the first collateral and borrowed token. And the last thing we need to do is we need to say who is sending this, because we're on a forked mainnet. We have access to accounts, test account. It's 0. And if all goes well, this is going to create a brand new vault, which we'll be able to pull from the vaults contract and see, yep, sure enough, went through, confirmation, we got the receipt. And if we look at the factory market count, we now see there's 2 markets, and our new vault has been deployed with index 1 to OX248. So you can now vault contract factory.vaults1 ABI equals vault ABI. We now have a my vault object that we can work with. And test against, do whatever we like. We've also included a script which you could use to run this on your own. This is under the scripts launch vault. This basically just shows everything we did here. It skips some of the steps, gets you to the exact same place. If you've got any questions, by all means, please feel free to contact us. We are very interested in helping you. There might be some initial warts, so you might want to wait till everything's in place. But if not, if you want to recklessly create your own factory, now you have all the skills to do so. Stay safe out there, friends.